Jose's food truck had $38,000 of revenue in 2009 and $90,000 of revenue in 2013. Let Y represent the revenue T years after 2009. Assuming the revenue is growing linearly, find the slope of the revenue line and give an equation for the line in the form y equals mt plus b. Okay, so in part A, notice that instead of an ordered pair having an x-coordinate and a y-coordinate, in this problem it has a t-coordinate and a y-coordinate. Now t, it tells us, is the number of years after 2009. Well, at the beginning of the problem, we learned that in 2009, the revenue was $38,000. Well, y is the revenue, so the y-coordinate of this point is 38,000. T stands for the number of years after 2009. How many years after 2009 is 2009? Well, 2009 is 0 years after 2009. So that gives us one of our 2 points. Then the second point is talking about the year 2013. 2013 is 4 years after 2009, so our t-coordinate is 4. Y is the revenue, and in that year it says the revenue was $90,000. All right, so the first thing it wants us to do in part A was to find the slope. Well, remember, slope is y2 minus y1 over normally x2 minus x1, but remember in this problem we have t's. So t2 minus t1, 90,000 minus 38,000 is 52,000, and 52,000 divided by 4 is 13,000. So that is the slope of the revenue line. Now, it also wants us to find the equation of the revenue line in the form y equals mt plus b, so we know that it's going to start y equals 13,000 t, and then we need plus the y-intercept. Now, the y-intercept happens to be this point right here. If you plot the point 0, 38,000, that point is on the y-axis. Anytime your x-coordinate is 0, that point is your y-coordinate, and so this is the equation of the revenue line. Y equals 13,000 t plus 38,000. Part B says, use your equation to project the truck's revenue in the year 2016. Well, 2016 is how many years after 2009? Well, it's 7. So that's telling us that t equals 7. It says project the revenue. It wants us to find revenue. Revenue is y. So it wants us to find y when t is 7. So using our answer to part A, y is going to be 13,000. We'll substitute in the value 7 for t, and then add the 38,000. So 13,000 times 7 is 91,000, and then 91,000 plus 38,000 is $129,000. That's our projection of the revenue. Part C. Use your equation, meaning the answer to part A, to determine in what year, assuming the linear growth continues, revenue first reaches 156,000. So here we're trying to find what year. Remember, the year is t. So we're trying to find t, and we're given 156,000. That's the revenue. So here they're telling us what y is. So substituting for the y in our answer to part A gives us 156,000 equals 13,000t plus 38,000, and we now need to solve this equation for t. So the first thing we're going to do is we're going to get the t term by itself by subtracting 38,000 from both sides. That leaves us with 118,000 equals 13,000t. And now to get rid of the t, to get rid of the number in front of the t, we divide both sides by 13,000. At this point, we want to use our calculator, and we see that t is about 9.07, which, since it's a year, we're going to round it off to the nearest whole number, which is 9. Now, this does not mean in the year 9 that the revenue is 156,000. It means, again, T doesn't stand for the year, it stands for the number of years after 2009. 9 years after 2009 is 2018, and that is the answer to part C.